2022 in space, the best year ever? Well, we did it. We reached the end of 2022. And as most people are doing their wrap-ups of what happened this year, it's fairly glum. You know, people are describing 2022 as a year. It exists. It's a year on the calendar, but you definitely wouldn't want to sort of think back and remember. But actually, in space exploration and astronomy news, 2022 was historic. And I think we'll want to definitely look back at some of the great stories that happened. Now, I'm going to do something a little different. Normally, each week, I am just reporting the news to you, but I'm going to provide some opinions. So if you want me to stay in my lane and you're not interested in how I feel or what I think about things, you might want to skip this video because I am going to express opinions, which is a thing that you're not supposed to do as a space journalist or as a journalist. All right, so let's get into the big stories that we covered this year. The top story, of course, is the James Webb Space Telescope. Now, it actually launched back in Christmas 2021, so I couldn't say that it launched, but it spent the first half of the year reaching its L2 Lagrange point, getting all of its science operations in order, and we saw those first images in July. And then we've been reporting on exciting images from the James Webb Space Telescope pretty much every week, all the way up till now. And I think there's a couple of controversies about JWST. The first is this idea of the release schedule. Of course, when JWST takes images, the images are proprietary to the scientists who requested the data for 12 months, and then it's released publicly into the general public. And a lot of people don't understand that. And a lot of people are trying to push to have all of the data released publicly immediately. And I'm ambivalent about that. On the one hand, I think, I want to see the pictures. I want to see the data. I want to see the information. But on the other hand, I want to make sure that the science gets done right. And of course, the problem is that if you take the data, you publish it immediately, then it's going to be a race for scientists to publish first and not necessarily to get the science right. Whoever gets the science first is the one who is going to get their name in the press. And I'm worried that that will degrade the overall quality of the science. But honestly, I am not a scientist, and a lot of very smart people think about that. And I would be interested in sort of what your thoughts and feelings are in the comments. The other thing, of course, is the name. JWST, James Webb Space Telescope, big controversy about that. I won't go into all of the details, but I do think that the fact that JWST was named just by one NASA administrator, it didn't go through the normal naming process, was a mistake. And I think that for all future telescopes, it should definitely go through a process where the name is chosen by a large group of people. They think through it very carefully, and we can get a name that everybody can be proud of forever. And then the last thing to say about JWST is just, it was really expensive and it was really late. And although it's so great to have it and have the amazing science, it's hard not to always think about what was lost. All of the science projects whose budgets were gobbled up by this incredible telescope. Could we have had a lot of other missions? Probably. So it's always bittersweet to think we're getting these amazing pictures, and at the same time, we lost a lot of other science. So it's hard to be completely enthusiastic about this telescope. But when you think about that budget, right, it was originally supposed to be a 10-year mission, but now it looks like because of the quality of the orbit, it's going to last longer. And in fact, I got a chance to talk to Lee Feinberg, who has been heading up the Space Telescope mission for pretty much its inception, and he had some really exciting news about how long the telescope is going to last.
You know, it's actually even more than 20 years. You know, it's like at least 20. I think people have been talking to even be potentially past 25 years. It's like,
really?
Yeah. I mean, it's, you know,
that's interesting. More than 25 years. Okay. If you haven't already, you should definitely watch that interview. I think it's like one of the greatest interviews that I've ever had a chance to do. It's not just about the telescope, but also the future of space telescopes, quantum telescopes. You should definitely check out this interview. The next big flagship story of the year is, of course, the first launch of the Space Launch System taking Artemis 1 around the moon. And the mission lasted several weeks. We kept reporting on it week after week, and pretty much every single part of this entire mission went flawlessly, from the launch of the rocket to the orbit around the moon to the return back to Earth. Every part of it was great. And what else could you hope for another mission that cost so much money and took so long and gobbled up the budgets of all kinds of other potential missions out there? On the one hand, it's exciting to know that we are going back to the moon, that humans are going to be setting foot on the moon in just a couple of years. And on the other hand, it's such an expensive rocket. To know that all of this space hardware, these beautiful RS-25 engines, are burning up in the atmosphere, crashing into the ocean, it just doesn't feel sustainable for the long term. And I don't think a lot of people feel like the space launch system is going to be sustained for decades and decades in the way that the space shuttle was. We know that there's probably going to be a half dozen launches for sure, and then who knows what's going to happen beyond that. And at the same time, there are a lot of other rocket systems coming out that could replace the space launch system. But we're in limbo right now. Do you wait for SpaceX to complete Starship? Do you try to modify a Falcon 9 or a Falcon Heavy to carry an Orion capsule or a Crew Dragon that can go deep space? Like, if you're going to go to the moon, you got to go to the moon. And there's only one rocket that can do it right now, and that's the Space Launch System, with all of its downsides and all of its upsides. Once again, I'm ambivalent. Like, if it was up to me, I probably wouldn't have continued on the shuttle program into the Space Launch System program. I would have focused on more reusable technologies, tried to figure out a way, modify Crew Dragon so that it can go to deep space, launch it on a Falcon Heavy, or maybe on an Atlas or something else like that. A way to bring the prices down into the hundreds of millions, sub-billion, as opposed to the $4+ billion that we're looking for each launch with the Space Launch System. But this is the plan right now. It is the law in the United States to build this rocket system. And so for now, we're just going to report on the news that happens. And again, it's hard not to feel excited that humans are going to be walking on the moon. Of course, if you want to get all of the details about the Artemis 1 mission, we did a very detailed video all about it from launch to landing, and you can check that out. We finally got an image of the Milky Way's supermassive black hole. I had to check. That was this year. Like, I'd almost forgotten. But of course, a couple of years ago, we got the image of the supermassive black hole at the heart of M87, which is a much larger, heavier black hole than the one in the Milky Way. And a couple of years later, we got the one for our own galaxy. And it's exciting because this one is close to us, but the really fascinating takeaway is that the accretion disk of this black hole isn't lined up with the rotation of the Milky Way itself. And astronomers had suspected this was going to be the case, but it's pretty amazing to actually get confirmation that this is happening. And so it's very weird and confusing that the black hole isn't lined up with the galaxy that completely surrounds it. It's been feeding it material for billions of years, and yet here we are. Really interesting. I have nothing but positive things to say about the Event Horizon Telescope and pictures of supermassive black holes in general, except more, please. Like, let's get a space radio telescope that can link up with this network to be able to create bigger images, longer baselines, start to grab more images of supermassive black holes in other galaxies. Because right now, M87 and the Milky Way's supermassive black hole are at the very limits of what the Event Horizon Telescope can do. But more black holes, please. Humanity reached out and smashed an asteroid. And of course, I'm talking about the DART mission, which crashed into asteroid Dimorphos. And this was, again, a really amazing success. For the longest time, we've thought about asteroids as this existential risk. We saw what happened to the dinosaurs. We know about Meteor Crater in Arizona. When an asteroid hits Earth, it's a very bad day. And is there some way that we can do anything about it? And of course, it's a trope of science fiction that you see a rocket launch and crash into an asteroid and save humanity at the last minute. But we did it. We actually sent a mission to an asteroid and smashed into it and were able to measure what the effect was. And what was really exciting about this is that the impact, pardon the pun, was much greater than we were expecting. And that's partly because the target, Dimorphos, is a rubble pile asteroid. And so when DART slammed into the asteroid, it not only imparted momentum to the asteroid itself, but it also kicked off debris, which imparted momentum to the asteroid, which made the whole thing a lot more successful than anyone was expecting. And this is a data point. And this will allow us then to look at future asteroids, figure out, are they rubble pile? Are they made of metal? Are they made of rock? And try to figure out what would it take to be able to push that asteroid off of a collision course with Earth. And we can imagine some time in the future when we have mapped out every single asteroid that is potentially dangerous. We are starting to send missions to start pushing some of them away from dangerous trajectories. And we're just making the solar system safer. And I think the big takeaway for me about this is just how much this feels like we're starting to take control of our space environment in the good way. Like we are going to be able to stop being completely at the whim to gravity and start being able to have a say in the matter. And we can see future missions helping to further our understanding of what it's going to take to keep this planet safe. This year, we got the announcement of the new Decadal Survey. And the Decadal Survey is where scientists come together, put together a wish list of all the different missions and observatories and experiments and just key discoveries that they want to make about the universe. And then they pass this along to the various funding agencies, and that will drive the development of new missions and new telescopes for the next decade. And the James Webb Space Telescope is a result of an old Decadal Survey. Many of the missions that you're familiar with came from former Decadal surveys. And so now we've got a new one. Reading through the Decadal Survey is wonderful because it feels like you're seeing into the future. You're getting a sense of what the roadmap is going to be for the coming decades of space exploration and astronomy. What we saw was a change in the demand for really big telescopes. We're probably not going to see this gigantic 15 meter LUVOIR telescope. We're probably going to see something that's a lot more similar in size to James Webb, something in the 6 to 7 meter class range, but it's able to see into infrared, ultraviolet, visible, kind of like the Hubble Space Telescope, but it will also have a way of blocking the light of stars so it can see the faint planets beside it. And this could be the tool that helps us see an Earth-sized world around a sun-like star for the first time. We saw the potential for a mission to Uranus, as well as potential missions to other places in the solar system that have been sadly underexplored, and we've got a lot of questions that could be answered for scientists. So I love the Decadal Survey. I've only reported on a couple of them so far in my career as a science journalist, and I look forward to seeing how this all plays out. China completed its Tiangong space station this year, and this was a long time in the planning, but actually the whole station came together quite rapidly. Now, it's not as big as the International Space Station. It only has a few modules, but they're able to launch the core module, the various other scientific and laboratory modules, and construct the whole thing, and pretty much mark the building of their space station complete this year. And they've had astronauts, who they call taikonauts, on board the station continuously for this entire time. And this is great. Like, having another nation that is capable of producing a human space exploration capability to be able to actually send a multi-part space station into space, that's a big technological achievement. And congratulations to everybody at China who worked on this. Now, I know a lot of people are concerned about where did they get the technology from? Did they invent it themselves? Did they license it from the Russians? Did they steal it from America? I think it's important to distinguish between a state that you don't like and the hard work of thousands of engineers and scientists who were able to build this rocket industry, launch a permanently inhabited space station into space, and then at the same time get angry about modules crashing down unpredictably to Earth. You can have many feelings all at the same time. And we've also been watching as the Chinese are preparing their plans to go to the moon. They've sent a bunch of rovers, orbiters, and it's like just today I read a paper about some proposed landing sites or places for a scientific station on the moon. So it's almost inevitable that we're going to see another space race with the Chinese putting humans on the moon within the next decade as well. China also announced that they're building their own version of the Hubble Space Telescope. It's going to be a little smaller, but it's going to be hovering nearby their space station so that they can bring it in, make upgrades, maintenance tasks, and then push it back out into space. which is, it's going to be great to have another Hubble-class telescope out there in space that we can pull the data from. This year we had to say goodbye to InSight, and that definitely feels sad. It's never a happy day to have to say goodbye to a mission that's been doing really well, working hard on another world. It was originally supposed to survive for 709 sols, but it ended up lasting for 1,440. So twice as long, which is quite impressive. And of course, like many of the other rovers and landers that have died on Mars, it's because its solar panels were covered by this choking dust that gets on everything on Mars. And whenever I say this, like, I just get in the comments all of these people saying, why didn't they just, and they should just, and we can all think of a whole bunch of reasons why. And the reason they didn't was because they had a budget to build a spacecraft. And when that budget was used up, they had built all the spacecraft they could. And if they put in budget to have windshield wipers or brushes, then they wouldn't have had budget for various scientific instruments or ongoing maintenance of the mission. So they had to decide what they were going to build and what they weren't going to build. And so they doubled the amount of time they were expecting, which is pretty great. I mean, when you think about Opportunity, I mean, it went on for like 10 years longer than anyone ever anticipated. It's amazing. But still, InSight did really well. And what I really love about this mission is that we just learned so much. We had this incredibly sensitive seismometer that was listening to the interior of Mars. That's so cool. It detected over 1,000 Mars quakes. It detected a meteorite striking the surface of Mars. And then people were able to follow up and find that exact strike and map it out. Farewell, InSight. Thanks for all the science. Speaking of missions that ended, we got the announcement that NASA has decided to wrap up operations of the SOFIA telescope. And this is this incredible infrared observatory in the back of a 747 that flies at a really high altitude and does infrared astronomy from the Earth. Before James Webb, there were very few ways to get a really detailed view of the universe in infrared. But of course, with James Webb Online, I guess there's some redundancy. You don't need to fuel up a 747 and fly it nonstop for hours and hours and hours when you can just make a few minutes of observation time with Webb. So the decision makes sense. And yet I loved this mission. I love this idea of putting a really big telescope in the back of an airplane and flying it around and mimicking what you could do with a space telescope, but being able to then bring your airplane, your instruments back down, upgrade them, improve the software, improve the hardware, make lots and lots of changes to it. And I think it's really important to have a platform like this to test out new ideas, new instruments, new observatories before you actually commit to building a space telescope. So SOFIA did its job. Now, if you want more information about this, I actually did an interview with the program manager, Dr. Margaret Meixner. I didn't know that the mission was going to be canceled. She hadn't announced that yet, but she must have known. So now when I think about this interview, the whole time she knows that SOFIA's days are numbered. But still, it's a really interesting interview, and what role airplanes and telescopes can serve into the future. So let's talk about some news that didn't happen, because there was quite a lot. We did see the mission of the Space Launch System, but you know what we didn't see? We didn't see a launch of Starship. We didn't see a launch of New Glenn. We didn't see a human launch with Starliner. We didn't see the Ariane 6 takeoff. We didn't see the Vulcan rocket. Like, a lot of other rocket companies have projects in the works and none of them launched. So maybe we'll see these in 2023. Now, if you want to learn more about the Vulcan mission, of course, I got a chance to talk to Tori Bruno, who is the CEO of United Launch Alliance, and he had a lot of great insights of what it's like to run a rocket company, but also what the future holds for the Vulcan rocket. So maybe we can get our answers there. We also got some pretty big delays. Of course, the ExoMars mission, which is carrying the Rosalind Franklin rover, that didn't go. And this is the first time that we had a Mars opposition, like the perfect time to go to Mars, and no missions went to Mars, even though the European Space Agency's mission was supposed to fly. And of course, that's due to Russia's invasion of Ukraine. The Russians were going to provide the launcher, they were going to provide the landing system, and they did not. They were busy invading their neighbor. So we know that NASA is going to be stepping in and filling in these parts, but it's going to take them a couple of years. There's a few more Mars windows coming up. They happen every 2 years or so. So hopefully maybe we'll see one 2028. We'll see. It sounds like I'm really excited, but the universe did disappoint me a couple of times this year. One is that I haven't seen a really bright comet, and the universe owes me a really bright comet that will streak across the sky, be visible from everywhere on Earth to the unaided eye. It'll be the comet of the century. Think back to Hakuro-r or Hale-Bopp. We haven't had a comet like that in decades, and we are way overdue. And the other thing is that we're hoping to see a meteor storm this year. There were some interesting possibilities. We made a big deal of it here on the channel, and there were none. So hopefully 2023 will be the year that we get to see a meteor storm. And to wrap up, I should do some information about the universe today itself. I think the big piece of news for us in 2022 was that we built our studio. I'm in it right now, and this has been wonderful. I have high-speed internet. I have a roof over my head that doesn't make noise when there's rain on it. I can control the lighting very carefully. It's just made life so much better to record video with. And hopefully you're seeing all of the additional content that I'm able to generate. And the other thing is I've been joined by Anton Pozdnyakov, who is a very experienced YouTuber from Ukraine, and he was able to jump in and help do a lot of our editing, a lot of the ideas, and really overall help produce the work that we do here at Universe Today. And if you're really enjoying a lot of the content, if you feel like the quality that we've been producing has been stepped up, I'm going to put 99% of that responsibility to Anton for making such a big difference in the show. But we also had just a lot of great work from all of the rest of the team at Universe Today, all of the writers, the other video editor, Chad, so programmer. It's been a really great year for Universe Today. One of the things that I'm proudest about is that we were able to increase the quality, increase the number of videos and content on the website, but without having to put a lot more advertising in everything that we do. And that is, of course, thanks to our patrons. And it was great. And I think, my hope is next year we'll be able to continue making things better and better, but without having to make intrusive advertisements, big, long sponsorships, things like that. And that's all thanks to the patrons. So I've said this before, but give a thanks to the patrons. But just in general, if there are creators out there that are doing work that you love, please consider supporting them directly. Join their membership, subscribe to them on Twitch, give them a donation through whatever ways that they do. Your support directly to the creators allows the people who make the things that you love on a regular basis. And it's a wonderful thing. It's so much better than advertising. It's so much better than paywalls. It's a perfect balance, in my opinion, for how to reward the people that create the things and for you to be able to get the kind of content that you like. So thank you everyone who supported us in 2022. Here is to an amazing 2023, which hopefully will be even better, but it's going to be hard to top 2022. You can get even more space news in my weekly email newsletter. I send it out every Friday to more than 55,000 people. I write every word, there are no ads, and it's absolutely free. Subscribe at universetoday.com/newsletter. You can also subscribe to the Universe Today podcast. There you can find an audio version of all of our news, interviews, and Q&As, as well as exclusive content. Subscribe at universetoday.com/podcast or search for Universe Today on Apple Podcasts, Spotify, or wherever you get your podcasts. A huge thanks to everyone who supports us on Patreon and helps us stay independent. Thanks to all the interplanetary researchers, the interstellar adventurers, and the galaxy wanderers. And a special thanks to Josh Schultz and Andrew M. Gross who support us at the Master of the Universe level. All your support means the universe to us. All right. Thanks, everyone. I'll see you next year.